Hello everyone, welcome to today's session. So today we are going to cover the introductions to trigonometry. So in this chapter, the topic that we are going to cover is trigonometric ratios of complementary angles. Okay, so let's look into the complementary angles. So this is trigonometric ratios for different angles, basically, for different angles, including the complementary angles. Okay. So we learned about what all trigonometric ratios we have. So we have sine A or sine theta, cos A, and we have tan A and cot A. And we also have cosecant A and secant A. So these are the 6 trigonometric ratios. Now, what are the values of these for different angles, right? For example, we have angles between 0 and 90. Those are the acute angles. So we will look at what values that we have for these trigonometric ratios for 0 degrees, for 30 degrees, for 45 degrees, for 60 degrees, and for 90 degrees. So first the simple thing that we can get is 45 degrees. So let me draw a right angle triangle here. Okay. Okay, so this is the right angle triangle, right angle at B, and this is A, and this is C, and the angle A is here. Now, in this right angle triangle, according to Pythagoras theorem, so this is the hypotenuse, this is the opposite side to angle A, and this is the adjacent side, correct? Now, what is the formula for Pythagoras theorem in a right angle triangle? The hypotenuse square, in this case AC square, equal to sum of the squares of the other two sides. So AC square I can write as AB square plus BC square, correct? Now, if I divide both the sides of this equation with AC square, let's see what will happen. So why I am telling you that is, if it is 45 degrees, if the angle A is 45 degrees, right? If angle A is 45 degrees, the opposite side and adjacent side should be equal. Let's say if this is X, this should also be X, because when we will get 45 degrees, if both the sides are equal, then only we will have 45 degrees there. So now both the opposite and adjacent sides are equal here. I am dividing with AC square on both sides. Let's see what happens. AC square equal to AB square plus BC square by AC square, right? So on the left hand side, what will happen? AC square by AC square becomes 1. And on the right hand side, I want to split that to AB square by AC square to each term, right? Then BC square by AC square. I can write that, right? And similarly, I can rearrange this, right? So can I write like AB by AC whole square plus BC by AC whole square equal to 1. So I applied the square for both numerator and denominator, because I have AB square by AC square, I can write that as AB by AC whole square. Now, if you closely observe, what is AB by AC? What is AB here? Adjacent side. And what is AC? Hypotenuse. So adjacent side by hypotenuse is nothing but cos A, right? So can I write this as cos A square plus what is BC by AC? BC is opposite side and AC is hypotenuse. So can I write this as sin A whole square, that equal to 1. Now, this is like cos square A plus sin square A becomes 1. This is one of the trigonometric identities. I think we move on to the identities. So let's focus on the angles, right? So 45 degrees. If it is 45 degrees, what will happen? The adjacent side, so which is AB equal to BC, that equal to X, right? If it is sine 45 degree, this is X and this is X. According to Pythagoras theorem, what happens? AC square equal to AB square plus BC square. Can we find what is AC here? So AC square equal to AB square means X square plus X square. So AC square equal to 2X square. Then what is AC? AC equal to square root of 2X square. Then AC becomes root 2 into X, right? So we found root 2X is what hypotenuse is. Now you just find the various values of sine, cos, right? Here. So sine A. What is sine A? A is nothing but sine 45. So sine A is nothing but sine 45 is nothing but what is sine formula? Opposite by hypotenuse. So what is opposite here? BC by AC. So what is BC? X. What is AC? Root 2x. So x gets cut. So the value is 1 by root 2. So the value here is 1 by root 2. So sine 45 I got as 1 by root 2. How about cos A? Cos A is nothing but A is 45 degrees. So cos 45 equal to adjacent by hypotenuse. In that triangle, what is the adjacent side? Adjacent is AB by AC. So what is AB? Is X. What is AC? Hypotenuse, which is root 2x. So cos 45 also I got it as 1 by root 2. Now let's look at the trigonometric ratios for different angles, right? So I want to find this for 30 and 60 now. Let's see. So here I'll take an equilateral triangle. Okay. I am taking an equilateral triangle. Let me draw it properly. Okay. Let's say this is an equilateral triangle whose side is A. Equilateral triangle means all the sides are equal. Now I will draw a perpendicular onto this line. Now this is right angle. So I am splitting that equilateral triangle into two equal right angles. So what is the angle in equilateral triangle? This is 60. This is 90. This total is 60. Half of the angle should be 30. This is 30 and this is 30 and this is 60. And here right angle at both sides. So I am trying to find like what is sine 60, right? In this triangle, let's say this is A, B, C, and this is at D, right? This perpendicular is at D. Now there are two triangles here. Delta A, D, B is a right angle triangle, and also delta A, D, C, both are two right angle triangles. Okay. Now from the triangle ADB, from the triangle ADB, can I write sine B? What is sine B? Sine 60 basically. Sine 60 equal to opposite side. Opposite side is AD here by hypotenuse is AB, right? So if this is A, we can find this value, right? What is this value? BD is A by 2 and this is also A by 2. So I can find AD, right? In this triangle. From delta ADB, if I apply Pythagoras, that is AB square, which is hypotenuse, equal to AD square plus BD square, right? The other two sides are AD and BD. So I'm squaring that. Now AB I know, that is A square equal to AD I don't know. So I want to find plus what is BD? A by 2 whole square. Now A square minus A square by 4 equal to AD square. I send this a by 2 whole square to that side. So this becomes 3a square by 4. If I take LCM as 4, then 4a square minus a square, which is 3a square by 4, that is AD square. Then what AD becomes? Root 3a by 2, right? So this AD value I found, that is root 3a by 2. Now I know all the sides here. This is a by 2, this is root 3a by 2, and this is a. Now what is sine 60? AD. What is AD? Root 3a by 2 by, what is AB? A. So AA gets cut, and the value for sine 60 is root 3 by 2. Understood? Now similarly, what is sine 30? Right? Sine 30 is what? Sine 30 is this angle, right? This angle. So sine 30 equal to, what is the opposite side here? BD by AB. So what is BD? A by 2 by A. So AA gets cut. Sine 30 value is 1 by 2. So in earlier case for 45 degrees, both the sides are equal in a right angle triangle. We found the value sine 45 and cos 45, that is 1 by root 2 and 1 by root 2. Now we found the value of sine 60 and sine 30. Similarly, we can find for cos 60 and cos 30 from this triangle. We just need to apply adjacent side by hypotenuse, right? So let's get into the next page. Okay, so in this triangle, what is cos 60? Right? Cos 60 means this angle I should consider. What is the adjacent side for this angle? BD. So BD by AB. So what is BD? A by 2 by A. A gets cut. So 1 by 2. So cos 60 is 1 by 2 here. Similarly, what is cos 30? So cos 30 is what? 30 is this angle and the adjacent side is this. So AD is the adjacent side for 30 degrees. So AD by AB. So what is AD? Root 3 A by 2 by A. So AA gets cut and you get the value of root 3 by 2. So for what we found? 45 we found, 30 we found, and 60 degrees we found. And 0 we need to find, 0 and 90. So I'll tell you here. Based on the findings that we have, there is a table we all need to learn, right? That's the angle. The angle is, what is the value for 0 degree, 30 degree, 45 degree, 60 degrees, and 90 degrees. Okay. Now, for which angles? For sine theta, cos theta. First, we will write for sine and cos, and then I'll tell you how to write for the other trigonometric ratios. We can write sine A also here, right? Sine A or sine theta, sine B, sine theta. We can refer any angle here. 0 degrees. Remember, sine 0 is 0. Because what happens in a right angle triangle? 0 degree means that is a base. So this is the right angle triangle, right? If this is the right angle triangle, I'll tell you here. So this is the right angle triangle, right? So this is the angle. If this is 0, this 0 means this line is here basically, right? It coincides with the base of the triangle. When it coincides with the base of the triangle, then there is no opposite side. For the triangle, it will be just a line. So there is no opposite side. So the length of opposite side is 0. So 0 by anything is 0. That's why sine 0 is 0. You got it, right? And sine 30. Sine 30 we found that was 1 by 2. And 45 we found that was 1 by root 2. 60 degrees we found that was root 3 by 2. And sine 90. So sine 90 means this angle becomes this, right? So this side is nothing but this side by Hypotenuse. So the hypotenuse and this side both becomes equal that time. So when I say 90 degrees, at that time, this value you will get as 1. Okay, so the hypotenuse and the length of this opposite side becomes equal when you draw a triangle for 90 degree. So the value for 90 degrees is 1. The value for 0 is 0. And for 30 degree, 1 by 2. 45 is 1 by root 2. And sine 60 is root 3 by 2. And for the cos values, cos is just the reverse of what these values are. So cos 0 is 90. Sorry, cos 0 is sine 90, which is 1. And cos 30 is sine 60. That is root 3 by 2. And this is equal. And this is 1 by 2. And this is 0. So basically, I can give you a hint. The values here, 0, 1 by 2, 1 by root 2, root 3 by 2, and 1, you can write in the reverse order. That is for cos. Now, let's write for tan. Tan is what? Basically, sine theta by cos theta, or sine A by cos A. So 0 by 1 is 0. 1 by 2 by root 3 by 2 is 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 by 1 by 2 is root 3. And 1 by 0. 1 by 0 is not defined. We cannot divide any number with a 0. So it is not defined. So that is tan theta. Now we have various others, right? The other trigonometric ratios are cos theta. What is cos theta? Sorry, cosecant theta. Cosecant theta is what? Reciprocal of sine. So 1 by 0. 1 by 0 is not defined. So 1 by 1 by 2 is 2. 1 by 1 by root 2 is root 2. And this is 2 by root 3. This is just the reciprocal of sine. And 1 by 1 is 1. And similarly, we can write secant theta. What is secant theta? Secant theta is 1 by cos, the reciprocal of cos theta. So 1 by 1 is 1. And this is 2. This is root 2. Sorry, this is what? Root 3 by 2 is 2 by root 3. And this is 2. And this is 1 by 0. This is not defined. So if you observe, sine and cos are in reverse order. Cosecant and secant are in reverse order. So not defined here, not defined here. 2 by root 3 here, 2 by root 3. So 30 is 60, 45, 45, 45 is same. 30 is 60, 60 is 30 here. Same like sine and cos. Cosecant and secant are also, we can write in the reverse order. Now, there is one left, that is cot theta. So cot theta is what? 1 by tan theta, the reciprocal of tan. So reciprocal of tan is 1 by 0. That is not defined. And 1 by root 3 is root 3. This is 1. This is 1 by root 3. And this is 1 by not defined is 0. So basically, tan and cot are in the reverse order now. If you look at the tan, 0 degrees, 30, 45, 60, and 90, here it is in the reverse order. So basically, if you know the first row of the trigonometric angles, 0, 30, 45, 60, and 90, you can write cos in the reverse order. Tan, you can divide and write. And cosecant, 1 by sine. Secant, 1 by cos. Cot, reverse of tan. So this table you need to remember the various values of trigonometric ratios for different angles. You need to remember, and how these angle values are useful in our. So how these angles are useful, we will see. We will see using we will see using some examples here. So let me take a screen print of your exercise. That way, you know, like what type of problems that can be asked in the board exam, right? So this is 8.2 exercise from the NCERT book. Now, if you look at the problems here, so directly they are giving sine 60, cos 30, right? All these values. So if you know the values, you can substitute and you can find the answers here. Okay, let's look at any one problem. right? So let's take the second one here, right? So I'm trying to solve the second one here. Yeah, this one. So what is this? 2 tan 45. So 2 times of tan 45 is what? 1. So 1 square plus cos 30. Cos 30 is root 3 by 2. So root 3 by 2 whole square minus sin 60. Sin 60 is also root 3 by 2 whole square. So if I simplify this becomes 2 into 1 is 2 plus 3 by 4 minus 3 by 4. So plus 3 by 4 minus 3 by 4, it gets cut. So the answer is 2. So you just substitute the value and find the answers, right? So for this, you need to be having a fair understanding on what values we get for different trigonometric angles. So these all you can just substitute the values. Let me do this third one, right? Third one is little tricky. So let's see. So here, if tan A plus B, so far we learned what is sin A, cos A, tan A, right? But here A plus B is given. So we don't know what is tan A plus B. So we need to think like how to solve this. Tan A plus B is root 3 and tan A minus B is 1 by root 3. Okay, so if I look at these values, the hint that I should get is, okay, so tan A plus B is root 3. But what is root 3? Root 3 is the value for tan 60 degrees. So tan A plus B equal to, for what value of, for which angle the value is root 3? This is for 60 degrees. So that means, can I say A plus B is 60? 60 degrees, right? So this is your equation 1. Similarly, let's look at the second one. So this is tan A minus B. So what is tan A minus B? 1 by root 3. So tan A minus B equal to, for which value of tan, that is 1 by root 3, this is for tan 30 degrees. Now, A minus B is 30 degrees. So this is equation 2. I will just add 1 plus 2 to find what is A and what is B. That's what we need to find, right? So A plus B is 60 degrees and A minus B is 30 degrees. So I'll just add these two. So B and B gets cut and this is 2A. So 2A becomes 90 degrees and A becomes 45, right? And substitute this value in any one equation. So for example, in the second equation, so A minus B is 30 degrees. So A is 45 minus B is 30. So B becomes 45 minus 30, that is 15 degrees. So A is 45 degrees and B is 15 degrees. So these type of problems they can give. You understood? So if you know the values for all the trigonometric angles, you can solve using this one. You can apply that knowledge and solve the problems. Now, we talked about complementary angles, right? So what are complementary angles? I have two angles, A and B, right? So if the sum of these two angles is 90 degrees, then we say these are complementary angles. Yeah, let's see. So when we say complementary angles, when we have two angles in a triangle, if those two, the sum of those two angles is 90 degrees, then we say this is complementary angles. So how these are useful, I will tell you. So sine 90 minus A becomes cos A. I'll tell you how. Let's draw a right angle triangle. Let's draw here. So this is the right angle triangle. Right angle at B, and this is A, and this is C. Now, what is this angle A? This is 90 degrees, right? What should be this angle? This angle is nothing but the total angle in triangle is 180 degrees, right? the sum of all three angles. So if this is A and this is 90, this should be 90 minus A, right? The angle C is 90 minus A. So if what is sine 90 minus A, that means, yeah, sine 90 minus A should be, first I will find that value, sine of 90 minus A, or sine C basically, that is, right? Sine C is opposite side, that is AB by AC. Similarly, find what is cos A. What is cos A? Adjacent side is AB and the hypotenuse is AC. If you see, these two values are equal. So can I say that sine of 90 minus A is nothing but cos A? Similarly, if we find cos 90 minus A, we will get sine A. Okay, so these two are complementary angles. So sin 90 minus A is cos A, cos 90 minus A is sin A. Similarly, we will get tan 90 minus A is cot A, and similarly cot 90 minus A is tan A. This we just need to remember, right? And similarly cosecant we have, right? Cosecant 90 minus A is secant A, and secant 90 minus A is cosecant A. So these are the complementary angles, trigonometric ratios for complementary angles. Okay. So when we say complementary angles, when the sum of the two angles is 90 degrees. So we just looked at like how we got this in a right angle triangle. So 90 minus A, sine of 90 minus A is equal to cos A, and cos 90 minus A is sin A. Similarly, tan and cot, and similarly cosecant and secant. So these are the complementary, these are the trigonometric ratios for complementary angles. So yeah, in this session, if I just want to give a quick recap, we looked at what different values, what are the different trigonometric angle values. So 45 we looked at, and then we looked at 30 and 60, and this is the table. This table is very, very important. So I gave you the hints how to write that table. So you just need to remember the first row. After that, you can just write the reverse order. Tan you can divide, cosecant you can do 1 by sine, secant you can do 1 by cos, cot you can do 1 by tan. And then we also looked at what type of problems that we get in the board exam. We just need to substitute the values and find the simplify and get the values. And then we looked at complementary angles. So what are the complementary angles and how the trigonometric ratios behave for the complementary angles. So it's basically sine 30 is nothing but cos 60. So cos 60 is nothing but sine 30, like that. Okay. So yeah, that's yeah, let me. All right. So thank you for your time. Thanks for watching this video. I hope you all understood the topic. Keep practicing, and I will see you next time. If you have any doubts, please contact me through my Urban Pro profile. Okay. Thank you very much.